In this lesson, we are going to continue and we'll also finish now the indices. Now, here we are dealing with solving equations involving indices, and we have to remember that the equations that involves indices are in two types. Number one, you may have an equation with a known index. The second one, equations with a known base. So, for example, the first one, we have 3 raised to the power x is equal to 81. So we can see that this time we are dealing with an equation with an unknown index. So the unknown is index. So x represents a number where if we raise that 3 to that number, the result is 81. So the first step that we need to do, we need to convert our 81 by writing 3. So we have to make sure that here we need to have the same bases before we do the simplification. So we can see that on the left side we have 3 as our base, even on the right side we have 3. So now we need to come up with what number can we raise 3 so that we give 81. So we can try by saying 3 times 3 is 9 times 3, 27 times 3, 81. So we need 4 3's. So this is same as 3 to the power 4. So since we have the same base here, we can cancel the base. So we can see that our x is equal to 4. Okay, let's look at another example. So the second example here, we get 2 raised to the power x plus 1 is equal to 64. So try pause the video so that you can see if you can get this one correct. Now we are going to do the same. So here we are dealing with an equation where we have an unknown index. So we need to have the same base. So what number can we raise 2 so that if we expand that to give us 64? So let's say 2 times 2, 4, times 2, 8, times 2, 16, times 2, 32, times 2, 64. So we can see that we need 1, 2, 3, 4, 5, 6. So we need 6 2's. So we can now say 2 raised to the power 6. So since we have the same base, we can cancel the base. Here we have x plus 1 is equal to 6. Then we can move this positive 1 to the other side, where we can have x is equal to 6 minus 1. So in number moves to the other side, the sign changes. So x is equal to 5. Okay, so now let's have another example. Okay, so the other example, let's say we have 5 raised to the power x minus 1 is equal to 125. So step number 1, we know that we have x minus 1, so we need to have the same base. So how many 5's do we need to have the result of 125? So let's see, 5 times 5 is 25, 25 times 5 is 125. So you can see that we need 3 5's. So over 5 we cancel, we have x minus 1 is equal to 3. We can collect the like terms by moving negative 1 to the other side. We have 3 plus 1. Our x is equal to 4. So this is how you would deal with equations where we have a unknown index. Now let's look at if we have an unknown base. Okay, so for example, we get the first example, 5 x raised to the power 2 is equal to 45. Then number 2, we look at 6x raised to the power negative 3 over 2 minus 162 is equal to 0. The third one, look at 3x times the square root of x is equal to 81. Okay, let's begin. So here now we can see that we have x as our base, so we are dealing with an equation where we have a known base. So the first part, we need to get rid of a number in front of x, so we'll divide by 5. Also here we divide by 5, so that when we cancel, we get our x raised to the power half is equal to 5 into 45. 5 into 45 is 9. Now there are two ways in which we can simplify, but let's use now we'll just look at one way. So we have x. So what you do is, if you have a variable like x raised to a certain number, which is 1 over 2 of a number, so you need to multiply it by the reciprocal. The reciprocal is a number that you can multiply by a given fraction to give you 1. So what you're saying is 1 over 2 multiplied by 2 is 1. 1 over 5 times 5 is 1. Let's say 5 over 3 times 3 over 5. 3 cancel, 3, 5 cancel, we get 1. So this is what we call the reciprocal. So the reciprocal of 1 over 2 is 2. So the reciprocal that we have introduced to the left side must also be added to the right side. So also 9 raised to the power 2. So that we can cancel these 2 and these 2, we have our x is equal to 9 raised to the power 2 is 9 times 9, which is equal to 81. Okay, let's move on to the second question, where we have 6x raised to the power negative 3 over 2 minus 162 is equal to 0. So the first step that we're going to do is we need to shift this negative 162 to the other side. So here we are going to have 6 raised to the power negative 3 over 2 is equal to, so if 162 shifts to the other side, we are going to get positive 162. Then from there, we say we need to get rid of the coefficient. So we divide by 6. Also here, we divide by 6. So x raised to the power negative 3 over 2. Now, 6 into 162 is 27, because we know that 6 into 16 is the remainder 4. 6 into 42 is 7, which is 27. Then from there, we said we need to multiply by the reciprocal, every part by the reciprocal. So the reciprocal of negative 3 over 2 is negative 2 over 3. Also negative 2 over 3. So that if we cancel this, we have our x. Then remember, from the first part of indices, we looked at where we have a negative index. We said this should be converted into the positive index. So this should be 27 raised to the power 2 over 3. So we can continue simplifying, which is 1 over, then we said the number below, the base here should be written under the square root, which is 27 here. Then our root is 3. So we are looking for the cube root. Then our power is 2. So 1 over the cube root of 27 is 3, because 3 times 3 times 3 is equal to 27, over 3 squared is 9. So our value is 1 over 9. Okay, now let's look at the last part here. So for the last part, we can see that we have an expression where we have a variable and a square root. So our step number 1, we are going to remove the square root. So after removing the square root, we are going to introduce 1 over 2. So root of x is same as x raised to the power half, which is equal to 81. Now from there, what we are going to do is we need to apply the law of indices, where we have the x here. We can see that we have the x here. So we can have 3x raised to the power 1. So since the bases are the same in terms of x, we are going to add the power. So 1 plus 1 over 2 is equal to 81. Then from there, we can simplify. So 1 plus 1 over 2. So 1 plus 1 over 2. Lowest common denominator is 2. 1 into 2 is 2 times 1, 2 plus 2 into 2 is 1 times 1, 1. So this is 3 over 2. So 1 plus half, we have 3 over 2. So this is 3 over 2. Now remember, we looked at the first example where we can break 81 can be written as 3 to the power 4. I'll just say 3 times 3 times 3 times 3, because I know that 3 times 3 is 9 times 3, 27 times 3, 81. So 3 to the power 4 is same as 81. So that when I divide by 3 here, I divide by 3 here. 1 3 will be cancelled. So we have x raised to the power 3 over 2. Then we can cancel here. We can see that we have 27. So we have 27. 3 times 3 times 3 is 27. Then we need to multiply by now the reciprocal, which is 2 over 3. Also here 2 over 3. So that when we cancel, x is equal to, here we are going to begin with the square root. Then under the square root, we need to put our base. Our base is 27. So then our root is 3. Then raised to the power 2. So x is equal to, the cube root of 27 is 3 raised to the power 2, which is equal to 9. So this is how you can answer questions of indices where you are solving for a missing variable. And that's it for this video. Thanks for watching.